Hello everyone, welcome to this video tutorial on Introduction to MATLAB. I am Krishna Mohan from Secpa Infotech Private Limited, which you all know maybe. It's the Northern India's largest training institute imparting technical education to engineering undergraduates in various engineering domains. Like we have courses for embedded system, BSTL, MATLAB. Then in engineering we have courses for CAD, CAM, CAD, and AutoCAD and CATIA. So we have lots of courses in various engineering and science domains. Okay, now MATLAB. MATLAB basically stands for Matrix Laboratory. It's the technical computing language. Technical computing, if I elaborate, is basically large calculation hard doing yourself. It will take so many years and it's very cumbersome and not possible for a human being. We have to generate subroutines or programs for performing such calculations. Those calculations can be related to finance calculations, or they can be astronomical calculations. So it was originally designed for solving linear algebra problems, but as the language has developed, MATLAB originally started in 1984, and up till now, it has added various other features like easy to use, easy to draw visualization tools like 2D graphs and animations, as well as we can design our own graphical user interfaces using. It's very easy developing such visualization tools in MATLAB. Okay, now let me not getting into much details. Let me introduce to the MATLAB environment. So if you have a licensed MATLAB version, you can just, if you have installed it on your computer, you will have such type of icon. We have basically this MATLAB 2008 software over here. There are various other higher versions available in market, like 2012B presently is available in market. So you just have to right click here, as we do with any other software. You can just right click and click on open, and you will this MATLAB software will be launched. So this is you can see the symbol is your trademark sign of MathWorks Inc., the company which deals with research and development of MATLAB. Okay, so this is your parent desktop, as we call it in MATLAB. There are several windows in it. Firstly, this is the command window. Command window is just like a DOS command prompt, where you can just write your program lines. You can write programs in single lines and press enter key, and it will be executed. Basically, MATLAB is an interpreter-based language. As you all know, that computer languages are basically of two types. One is your compiler-based, if I classify on that basis. One is your compiler-based, and one is your interpreter-based. So this is MATLAB is an interpreter-based language, in which means as soon as you write a line, means it line by line. Means if you write a line and press enter key, it will be executed, and then it moves on to the next line, like that. Okay, so this was all about command rows. Like let me show you an example. If I just write it here, a is equal to 2. So as soon as I press this enter key, it will be executed. Means a will be assigned this value 2, and this is Workspace. This window is called Workspace. This is a temporary storage area of your variables. Whatever variables you are creating during a MATLAB session. Now, what is MATLAB session? MATLAB session is just like it's just when you start MATLAB until you quit MATLAB. So during a MATLAB session, whatever variables you are creating, those are all temporarily stored over here in Workspace. Now, this is your command history. Whatever commands you have used in recent times, they're all stored over here. You can just fetch them, retrieve them just by either copying it. You can just go and press this right click here, and you'll have this copy option. You can just copy it here and paste it here, so that you don't have to type it again and again while in programming. So you can just do this. You can copy that from here, or either you can use arrow keys, up and down. I'm using this up and down arrow keys to retrieve all previously used commands. So this reduces your effort in programming. You can just copy those commands or retrieve those previously used commands. Okay, now this is your current directory. The current directory which you are working in, its name appears here, and whatever files, whatever MATLAB recognizable files are present in this directory, they are all shown here. Now, if I am talking about these MATLAB recognizable files, like there are files with certain extensions which MATLAB recognizes, which are MATLAB files like .m. Then we have .m for you'll see that .m, then .mat, then .fig. So these are some MATLAB recognizable file extensions which MATLAB recognizes. Okay. Now we have certain shortcuts, certain icons made over here. Let me explain this to you all again. This is for opening a new M file. Now, what is M file? Simply, M file is a file having .m extension. Basically, here if you see, if I write a command, if I go on writing a program in command window, suppose if I go on writing, suppose if I make a matrix, simple command is here. Suppose A is equal to a random matrix of, what I suppose, 600. So see what happens. The whole screen is filled with this numbers. Similarly, this is not a very feasible idea of writing your programming codes were here, because as soon as the this screen has such a certain limit, as soon as that limit goes over, your codes will be lost. So it's a better idea to write it in a editor window. You can use any of the editor windows, like you can use your text pad, or you can use your Word, MS Word, but it's better to use built-in editor, which is your blank M file. Just go here, new blank M file. You can write your codes here. This is a rough space. Let me show you. Editor. So this is a rough space where you can write your whole code all together. It's not like command window. As soon as you write your code and you write a line and press enter, it will be executed. No, it's not executed. It's stored here unless until you press this run button, or either you call this file. So likewise, see now this workspace. Whatever variables are available here, these are temporarily stored over here. Means they are just for this particular session. If you clear them, if you clear these variables using this clear command, we have clear command in MATLAB for clearing workspace variables. Suppose if I clear it, clearing these variables are lost. So if you want to store, if you have created some data, if you have got some output and you want to store it somewhere, you have to store it in mat files. So let us suppose let us make some data. A is equal to 2. Suppose A is equal to 2 has been created and it is now being shown in workspace. You want to save it, you have to just save it like this and save. It is saved with an extension .mat. So likewise, MATLAB has several file extensions which you can use. Okay, CLC clears this command window, stands for clearing command window. Okay, now let us see a basic example of drawing a graph. Basically means, as I told you earlier, that MATLAB integrates computation. You have already seen that we just use one command and we had matrix 600 by 600 matrix created. So for computation, it's very easy. Means let us take an example of computation. Suppose if you have to add two numbers in C, you will take at least 7 to 8 lines. You will have to include several header files. Then you have to initialize certain, means int A, int B. You do like that, and then lots of instructions. And then after that, the core thing, that A is equal to this, and B is equal to this, and C is equal to plus 3. But in MATLAB, it's as straightforward as doing it on your calculator. You just have to write A is equal to 2. Then suppose B is equal to 3. And then C is equal to A plus B. It's as easy. So MATLAB programming languages clears all the formalities. You just concentrate on the basic code, what you have to actually do. So it's just like doing as you are doing on your copy pen, or as you are doing with your paper and pen. It's just like that. Similarly, let us take an example of drawing a simple sinusoidal graph in MATLAB. It's as easy as doing on your as you do on your graph paper. Let us take an example. Suppose if I ask you to draw a sinusoidal diagram on your graph paper, what you will do? You will select an x-axis, a y-axis, and then you will select some x points arbitrarily on your, because that is an independent variable. So you will select some points, and then depending on that sign rule, y is equal to sin x, your y is your dependent variable. So you will generate some points on those x's, and you will have an axis coordinate combination for each point, and you just join it, and you will get a graph. Same procedure is used by MATLAB. So what you have to do, just create a space, create a x-axis. Suppose I am creating that axis by the name of t. So t is equal to, suppose I have certain points. Let us take it as matrix. So 0, then pi by 4. Let us take, then pi by 2 into pi by 4, then 3 into pi by 4. Likewise, you can take certain points on which you want to draw your graph. 5 by 4, 5 into 5 by 4, 6 into 5 by 4, 7 into 5 by 4, 8 into 5 by 4. So this will create a x-axis space from 0 to 2 pi. 8 pi by 4 is 2 pi. So this is it. And then use this rule, y is equal to sine of t. So it will take these t arguments from here and calculate sine of those t's and save it to t variable. This is your sine t. See, as I am writing all these commands, as I am writing these lines, all the variables are being created over here. Okay. Now sine is a built-in function in MATLAB which you can use for getting the sine values of whatever arguments you have passed in H. This is the argument, t argument over here. Okay. Now plot is a 2D dimensional 2D line plot command in MATLAB. You can just use it to plot a simple 2D graph. So plot t comma y. If I pass it here, the x-axis value is passed first as the first argument, and the y-axis value is passed as the second argument. See, on pressing it, we have this graph generated. Okay, this graph as you see is not a proper sine graph because we have taken very less points. If we take more number of points, it will include certain other some more points. Like let me take some more points on t-axis, on the x-axis. So I will use this command y is equal to 0, 0 to, let us take the interval of 5 by 12. This is a straight line. This is known as vectorization command in MATLAB. Details you can will take later on. So 0 to 5 by 12. This is the interval of 5 by 12 and up to 2 pi. So this will create an x-axis with the interval of 5 by 12 and spacing of 5 by 12 and up to 2 pi. So giving this new command, and then again using this previous command y equal to 90. I am using this time this arrow keys, up and down arrow keys, to retrieve this previously used command instead of rewriting them. So y is equal to sin t, new y-axis points, new ordinate points will be generated, and then again this plot command. Now you can see that this sine curve is okay. This is a smoother curve. So you will have to take this fact also in mind, that when you are drawing a graph to get exact, you will have to include a sufficient amount of points, sufficient number of points for us to get a good graph. Okay, so this was an example of 2D graphing. Similarly, if you want to generate a 3D graph, let us draw a plot of helix. So let me clear command window. CLC, as I told earlier, is the command for clearing command window. So clear command window. Now suppose if you want to draw a 3D graph, it's as easy as drawing this 2D graph. It's just a simple addition, like this 3 will be appended at the last of plot command, and we'll have to include another axis. So we'll have to define points for that axis also. So t, same t we are taking, and y is equal to sin t we are taking. And for ellipse, since ellipse is basically a circle elongated into the third dimension, that is the z dimension. So we'll have to plot a circle first. So plotting a circle will take the parametric form of circle. For a circle, the parametric equation is y is equal to x is equal to cos t and y is equal to sin t. So we'll draw those points. Z is equal to cos of t. Already we have sin t, so cos of t. Cos is another built-in function, mathematical function in MATLAB, which you can use to generate cosines of the arguments which you have passed inside it. So that is so z is equal to cos t, and the third direction. Suppose let me take it as t. Whatever, you can take any variable name. U is equal to, suppose, 2 into t. This is for the third dimension, z dimension. And then we'll pass these points to plot 3 function, and in the order of z, y, u. This is for the x-axis, the first coordinate. As you can see here, as soon as the one important aspect in MATLAB, one important feature of MATLAB is, as soon as you write a command anywhere, the usage of that command, means how you are going to use that command, is shown over here. So it's very easy to use, easy to learn also in that respect. So first point z, because if you're drawing a circle, cos t sin t, so z, then y, and then the z axis point, this u. And pass to it, we'll get a plot of helix. Basically, we have taken the interval from 0 to 2 pi, so it's showing just single helix. So again, we have to make a change again, as we have done in last time for that sine plot. So we have to increase the number of circles in that helix. So just a simple amendment: y is equal to sin t, and then again z is equal to cos t, and this u is equal to 2 into t, and then again plot 3. And now you can see that we are getting a proper helix of 5 circles, you can say, or 5 revolutions, you can say. So these were some simple examples through which to elaborate the power of MATLAB, how you can draw simple graphs and visualize the things in form of 2D graphs and 3D graphs. Just do some calculation, do some programming, visualize the results in the form of tables, analyze them using this 2D and 3D graphs, and proceed further. So this is a general design procedure in which we can simultaneously do the coding, do the programming, do the calculations, and simultaneously see the graphs, because graphical results are important. Graphical 2D and 3D graphs are important in each and every field, whether you're a scientist or engineer, or whether in finance sectors also we require several types of graphs like pie chart, bar diagram, etc. So we have functions, built-in functions for all these. Okay. So another feature of MATLAB is its toolboxes. Very important, very exclusive feature of MATLAB is its toolboxes. MATLAB has more than hundreds of toolboxes available relating to different branches of or domains of engineering, science, and as well as day-to-day life, finance, etc. Like to list some of them, like we have control system toolbox, image processing toolbox, signal processing toolbox, sorry, then financial toolbox, communication toolbox, neural network means related to different branches of engineering and sciences and various other fields. We have collection of functions. Toolbox are basically a package in which we have domain related built-in functions already stored in. Means we have to just call those functions and use them directly in your own coding, in your own code. Okay. Now some more examples, some more graphical examples of MATLAB which I want to show you. Like if you are a control engineer, you may be aware of this graph. This is a root locus plot. Root locus plot you may be designed for stability analysis. Basically, if you remember, it is for stability analysis when you are designing any control system. For stability analysis, we have this root locus plot. So we have this function rlocus in MATLAB, which you can directly use, pass it required transfer function, and it will automatically draw this root locus plot. Similarly, we have board plot and Nyquist plot. We have functions for finding out board plot and Nyquist plot. So these are all built-in functions which you can directly use. So likewise, for various other domains like for communication engineers, for signal processing engineers, we have built-in functions which you can directly call and use them in your own programming to visualize or see your results. Okay. Now, I was talking about Simulink. Simulink is an associative software of MATLAB in which you can program in graphical way. I can say, like in MATLAB, you use programming, or you can use toolboxes, functions, built-in functions. Means there you have to program, write a code for generating certain application. And Simulink, we have to just we have prototypes already built in the library of Simulink. See, let me show you the shortcut. Let us go to here, and this is the Simulink shortcut. Either you can write Simulink over here, Simulink on command prompt to go to the Simulink toolbox, or whether you can click here also. So let us go through this through writing on command and pressing enter. So Simulink. So this Simulink window will appear, and you can see the library. The library of Simulink contains built-in prototypes of various graphical blocks. Let me show you that. This is your Simulink library browser, in which we have see, these are all block diagrammatic representations of various functions. Like suppose we have been using sine function. So sine function is available here. So here, instead of writing those commands, we have blocks. We just have to copy those blocks into our design and just join them as you do in any other CAD software, computer-aided design software, like you may have used OrCAD or PSpice. So likewise, you can draw your designs block diagrammatic. An example of such design, a control system design, is shown in this presentation. You can see here. This is a simple control system in which step input is being given to this control system. This is a plant. Feedback is being given feedback of 1 is being given here, negative feedback, and you can see the results over here. A scope block, oscilloscope type of block is available by the name of scope here in sync library, and you can see these results over here. So this is how you can do in Simulink. Let me show you an example. Let me show you a design in Simulink. A simple design. See, we'll go to new model. This is the shortcut for it. New model. Let us make a simple sinusoidal graph. For that, we'll require a sine block. Add to untitled, and then to see this sine function, we'll require a sync. Sync means where the final signal is going to emanate. So here, and just join it. You can join it simply clicking here, dragging the mouse, stopping here, it will join like this. Okay. So you can set the parameters also, like you can by default it is time based. So certain parameters are there. You can suppose if you want to change the amplitude, because the default amplitude is 1, if you want to change it to 5, and sinusoidal signal of 5 amplitude. So sinusoidal signal, this parameter has been set, and just you have to run it from here, this play button, and it will run. It is running up to 10 seconds. So you can see here the result. This is the sinusoidal plot. So that was one way I told you how to draw it using commands. We are writing commands, just writing t, assigning the x-axis t variable, then passing this y is equal to sine function to y variable, and then using the plot function. And this is your graphical approach, block diagrammatic approach to perform the same operation. So this is all. This was all about this introduction. About introduction to MATLAB. So we are basically imparting this course for more details, for better. This is how you can draw simple sinusoidal diagram using Simulink. Another example you can see here, an animation example in MATLAB, how to generate an animation in MATLAB. So this is the slide. Show you. This animation has been built in MATLAB. Basically, this is a peach function which is propagating in crest and brush form. So this you can generate such sort of animation also in MATLAB. So this was a short introduction about the MATLAB software, various features. For more details, for better perception of this language, you can come to any of our centers. So that was all about introduction to MATLAB. We'll be coming with further add-ons, further tutorials related to MATLAB in our further sessions. And apart from that, if you want further training, we have 4 weeks course, we have 6 weeks course, we have 6 months course. So you can come at any of our branches in Noida, Roorkee, Lucknow, or Chandigarh.